Good evening, everyone. Welcome to today's Talk presentation. Today, the speaker, Pratyusha, is going to deliver a topic which is on deep learning based six-type classifier for lung cancer and mimics for histopathological whole slide images. Yeah, our speaker, Pratyusha, she is an AWS and app developer at Renix Life Sciences. She is responsible for AWS services and their integration along with the cloud technologies, such as AWS Lambda, EC2, and S3. She is responsible for designing, developing, and testing iOS applications and maintaining the AWS infrastructure. Pratyusha has a bachelor's degree in information technology from GMR Institute of Technology, Rajam, which is in Andhra Pradesh. She has also completed various projects in app development and machine learning. At Renix, she has the opportunity to work on various projects which will help to enhance her development skills. She is gaining a thorough understanding of cloud technologies such as AWS Cloud, Google Cloud, and also the Microsoft Azure. Yeah, I would like to invite our speaker Pratisha to give a topic to deliver this topic. Yeah.
Thank you, Shruti, for the introduction. So, when coming to the topic, deep learning based six-type classifier for the lung cancer and mimics from histopathological whole slide images. And this is the topic under the new technologies related to lung cancer. So, this topic has a major impact on the accuracy and efficiency of lung cancer diagnosis and how it works, reduce the cumbersome workload of the pathologist. So, let me get into the topic. So when coming to the introduction of this lung cancer six type classifier, so basically this lung cancer is a global health concern which is responsible for a significant number of cancer related deaths each year. We can see that early and accurate diagnosis plays a pivotal role in improving these patient outcomes. And however, we can say that only 16% of lung cancer cases are diagnosed at an early stage. If we identify an issue or we identify the lung cancer and in an early stage, we can try to rectify it, but because of this we cannot. Only the 16% of lung cancer cases were getting diagnosed. So we are having a many strategies to diagnose this at an early stage. So we are having one particularly promising area of research is it is the use of deep learning based classifiers or deep learning based methods, which can be where the accuracy can be high. And this is, to benign the lung cancer conditions through the analysis of histopathological whole slide images, which are histopathological whole slide images are which are nothing but the digital images. These digital images which are sectioned and stained tissues. These are the section and stained tissue samples that are scanned and digitally recorded at high resolutions. So to design and train a deep learning based six type classifier for the automatic categorization of lung histopathological WSIs. So basically, this study, it mainly aims to investigate and develop these classifiers. So those, what are the six type classifiers? Like for example, here we have been the lung tissue images into six different categories. Those are adenoma carcinoma and squamous cell carcinoma, small cell carcinoma, non-small cell carcinoma, benign lung lesions, and normal lung tissues. So to investigate and get the deep learning based classification for enhancing this accuracy of the lung cancer and its mimics. So the basic general background of this topic is early and precise diagnosis is very crucial and improving patient outcomes. One of the key tools in diagnosing lung cancer is histopathological examination of tissue samples, where the pathologist analyze tissue samples on glass slides under a microscope. And this traditional method, which is accurate, but it can be a time consuming also and subjective depending on the pathologist's expertise. If he is not an expertise, and we can face very issues. So these deep learning models, which are inspired by the structure and function of the human brain, and it have demonstrated an incredible ability to learn and recognize these complex patterns within the large data sets. And these models, which it analyzes the medical images and tissues, which are providing a potential solution to some of the challenges which are associated with the traditional diagnosis methods. And we are having some of the key challenges here, like classification of multiple lung conditions. Like we are not only having a single condition of a lung issues, like we'll be having many things which can be classified using this histopathological, but previously in the traditional method it cannot be observed. And the inter-observer variability also, and it reduces this inter-observer variability, which is like manual assessments and these all, and efficiency and speed. So when we are using these deep learning methods, we'll be having a high efficiency and very within a less amount of time, we can say, and potential for early detection. We can easily detect a issue or a problem within an early stage. It will not be long lasting to the more research and all. It will be taking a less amount of time, and it will be getting sorted it out. So these are the main background factors. These are the main pivotal factors in the patient survival rates. So these are the key challenges in the general background. So when coming to the present challenges, as we have discussed about the traditional method, what we have been doing every time. So the present challenges is like we are using the 6-type classifier, which refers to this deep learning system that can distinguish these 6 major categories of lung cancers, and they look like based on the information contained in these digitalized whole slide images, such as a classifier could significantly aid the pathologist by providing more consistent on objective diagnosis support. And here in these while using these deep learning methods that manual analysis, like we can easily consume the time, like we don't need to take much amount of time for detecting the lung cancer, for making a treatment for the lung cancer and all. We don't need a much amount of time than compared to the traditional method. And the potential for misdiagnosis, and this lung cancer and various subtypes, it can be sometimes challenging to distinguish the accurate one. Like when you observe a issue with an accurate and a naked eye, you'll be getting some issues. But if you are using some machines or else using some deep learning methods or algorithms, so it can be a better easy method, leading to incorrect treatment plans or unnecessary interventions. So other one is cumbersome workload, and the demand for the rapid, accurate and consistent lung cancer diagnosis is overwhelming without the aid of deep learning techniques. Like for example, the workload has been decreasing while we are using these deep learning methods. For example, it can reduce the workload of a pathologist. It can reduce the work of their um things like detecting and everything. So once the workload has been decreased, they can detect earlier. So the limited utilization of big data and the missed opportunities for early detection. So these are the present challenges we will be faced. We have faced. So we can use this 6-type classifiers. And the next is objective of the research. So the primary objective of the research is to leverage the advanced deep learning techniques to it is to enhance the accuracy. The main thing we are focusing on here is the accuracy and the efficiency of the system. So for this we will be addressing only few things, like developing a deep learning based classifier, contribute to early detection, examine the clinical implications, enable personalized treatment, enhance diagnostic accuracy, evaluate diagnostic performance. So these are the main objective of the research. So when coming to the methodology, so here the study of the deep learning based 6-type classifier for lung cancer and mimics from the histopathological whole slide images, it is important for understanding how the research was conducted, and how the data was collected and data was pre-processed and all. So actually these are having some of the, it consists some of the process. So the research begins with the acquisition of large data sets, like large data has been acquisition, and with these histopathological whole slide images with some type of sizes, and those images comes from various sources such as like medical institutions, research repositories and all. So they are typically annotated to different identify the type of a lung tissue, including the malignant and benign cases. like pre-processing steps, including that what are the things we need to have and all. So in the first process was collecting the data and pre-processing the data. Firstly, we'll be collecting all the images from the and all, and we'll be pre-process the data. I mean, we'll be processing the data using the standardization of image sizes. Like a particular image should have a size and the color normalization and removal of artifacts, and it will be everything according to the system we need to do it. So the data collection and data pre-processing will be done in the earlier stage. And the next stage was data set splitting. So the data set is divided into some of the types like training, validation, and so the testing set is mainly used to teach the deep learning model, like I mean how to I mean it is also called as a test cases we'll be calling, right? So the testing set is same like that. And while the validation set helps in tuning the hyperparameters and preventing the overfitting, whether it is validating the correct one or not, whether it matches the detection, while I mean it is detecting correctly or not, like that. And that training is nothing but we'll be training the model based on the images we got from the WSA, like the images, like what are the types we got from the things we got from the data pre-processing method. So the next one is deep learning model training. So in this model training, the deep learning model, it is used it is trained using the training data set. And during the training, this model learns to recognize various features and patterns in the lung tissue images and in different lung conditions. So based on that, it will be cybercating, like what is the lung condition of a present image, and whether it is having a lung cancer or what, like that. So it is basically the model training. So here we'll be having some of the functions like the loss function, the optimizer, and learning rate, which are configured to guide the model in I mean minimizing the prediction errors and improving its accuracy. And the next one is model evaluation. So basically this model evaluation, it is a final evaluation of the deep learning model performance. It is conducted using the testing data sets, which we have already seen in the model data set splitting. So in this the model accuracy, precision, recall, F1, these are all which are other relevant metrics. So these are the metrics are computed to assess its diagnostic capabilities, and based on all these, the model will be evaluated. And the next step goes to the interpretable AI and explainability. Like we'll be giving a medical decision making efforts which were made to provide the interpretability and explainability of deep learning models predictions. Like we'll be giving this decision making thing. So this is the steps which are used to develop the system. So this process encompasses the data collection, pre-processing, model development, and rigorous evaluation to ensure the reliability and clinical relevance of the proposed six type classifier. And we can see this in the methodology. Here we are having images, like this is annotated by the pathologist. For example, it will be extracted by the ROS, like which region of interest, like for example this is a image, and which region it is needed. So it will be cropping into these styles. These images are cropping into these styles. And then see, this is 256 into 256. It is nothing but the image sizes. Like in this size it will be stored, and then it will be giving into the model input. As we've seen in the data set splitting, we have three types, that is training set, validation set, and testing set. So this model input is divided into these three things: training set, validation set, and testing set. And then this multi-center cohorts, it is nothing but like what are the classifiers we are using for the pre-processing of the data, and how the process data is processing, like that. And after that, after checking everything, first pre-processing will be done, and then the validation, testing, training, and evaluation. And at last we'll be comparing with the efficient six step histological classifier. So this is about how this method works and what is the structure of the method. And when coming to the results, like this model achieved high accuracy on all six type issues, like with a 0.965, that is nothing but almost everything was with a positive rate, and it also achieved high consistency with a ground truth and attending pathologists, and we can observe this in a graph. So the others, they also implemented that a threshold based tumor first aggregation method for slide label inferencing. And you can see in this graph, like here you are having a false positive rate like this. I'll be explaining what is false positive rate and all. Actually, this deep learning model, it is proved to be not only accurate but also efficient, significantly like accelerating the diagnostic process compared to manual assessments. Like this graph shows that the false positive rates for a deep learning based 6-type classifier for lung cancer and mimics from histopathological whole slide images on they are tested on 4 different data sets like SYSU, SYSU2, SZPH, and TCGA. These are the data sets which we have already known, like some of the things like cell carcinoma, adenocarcinoma, and squamous like that. And this false positive rate is nothing but it is a percentage of cases where the classifier predicts that a patient having a lung cancer when they actually do not. So the lower the false positive rate, the more the accurate classifier is. So this graph shows that the false positive rate for the classifier are very low on all the 4 datasets. You can observe it here. For example, the false positive rate of the classifier on SYSU1 is 0.2% at a true positive rate of 96%. This means that the classifier is very good at identifying lung cancers without generating too many false positives. So this graph also shows that the false positive rates for the classifiers are lower than the false positive rates for the pathologists. Like whenever we do it in a microscope and we observe everything with a naked eye, we'll be making some false positive issues. So that is too much lower than this. Like sorry, the way we are comparing with the deep learning method and with a traditional method, the accuracy of the deep learning method is very high, and the when compared to this deep learning and this traditional method is a bit low. So overall, this graph shows that the deep learning based 6-type classifier is a very accurate tool and for diagnosing this lung cancer, and it has low false positive rates and outperforms pathologists in terms of accuracy. So, and these are the tissue predictions, like we have been using this WSI images, right, like whole slide images. So how the tissues has been things for the 6 types of classifiers: adenocarcinoma and squamous cell carcinoma, small cell carcinoma and all. So these are the 6-type classifiers and how it is going on like that. And the mainly the limitations were like it will be having a limited data set size. The data set size should not be increased more than that. Like it is having 1067 whole slide images, and other than that, overflow of our data sets or overflow of our images cannot be accepted. And lack of validation in a clinical setting. So it should be validated in clinical setting. So this need to be a validation. This is the mainly one of the limitation, we can say that. And main conclusion is that I can conclude that this deep learning model, it is a promising tool for the classification of lung cancer and its mimics from the whole slide images. And the model achieve high accuracy on all 6 type of tissues with AUC above 0.96, which is a 96% true rate for all the classes. And it also achieved this high consistency and efficiency also. So I think this is the pivotal step toward the future where the artificial intelligence complements human expertise. So deep learning models or deep learning methods are very appreciating, so that the lung cancer detection will be very easier at the earlier stage, and we can improve the survival rates also. So yeah, I want to conclude it like that. And the main impact of the research is like it has a high accuracy in all tissue types, and it can be suggested that it has the potential to improve the accuracy. And the second one is the pathologist workload will be decreasing, cumbersome workload, because we'll be facing much workload because of getting to knowing, I mean, using the traditional method and all. So it will be helping to reduce the workload for solving these some of the automated tasks. And the third one is using this artificial intelligence and deep learning methods and innovative approaches. It transforms the way we diagnose and the treatment of a lung cancer and its mimics. It will be leading to a precise, timely, and personalized medical interventions. Thank you.
Yeah, thank you, Pratisha, for your detailed talk. Now the session is open for audience questions. Is it a multi-class classifier? If so, how many FPR is defined?
Yeah, actually, it is a multi-class classifier, ma'am. Like, it will be classifying the data based on this six types classifiers for now. So I'll be getting to know about this FP, how the FPR is defined.
Yeah. Next question is from Vijay sir. How did the model perform in detecting accessory features such as grade of tumor? Grade of tumor.
Yes, sir. Actually, in the first stage, we'll be, I mean, collecting the data and we'll be pre-processing the data. So when we collect the data of the data sets and all, we'll be segregating that based on, we'll be segregating every section of the cancer, like this indicates this, and what are the factors it will be indicating like that. So based on those features, it will be detecting like whether it is a early stage, or else whether it is a tumor which is an ignorant or something. So based on that data sets and based on that detection, it will be checking that whether it is on which grade of a tumor, like that.
Yeah, so I hope that's helpful to your question. Yeah, by this I can conclude that there is no questions from the audience. Yeah, Pratisha, can you open your last slide?
Yeah.
Yeah, our upcoming presentation was given by Vijay Padal sir, which is on 25th of October, on the topic sex and age dependent genetics of longevity in a heterogeneous mouse population. Thank you for your patience and joining for this CELTOP presentation. Thank you, everyone.